Okay, good evening. Good evening, everyone. I hope I am audible to you. Yeah, thank you, Mr. Pawan. Okay, thank you. Okay, myself, I am ML Narsimam. So we are going to discuss the subject roughly 60 to 65 hours. That is the estimated hours, 60 to 65 hours. We are going to discuss. First, let me discuss what is the syllabus we are going to cover. What topics we are going to cover in signal subject. First, let me discuss the syllabus. The first topic of signals we are learning is introduction. Like, what is the definition of signal and what are the types of signals we have and what are the classification of signals, then what are the different forms of systems we are having, that we are learning in the first topic. Introduction. Second topic is linear time invariant systems, in which mainly we are learning the word convolution. LTA systems, in that mainly we are learning the word convolution. Convolution is used to obtain the overlap portion between two different signals. Convolution is used to obtain the overlap portion between two different signals. If you know an input and system, how to get the respective output, that is decided by the word convolution. That we are discussing in the second topic. Next, we are starting the Fourier series. The first frequency domain concept is Fourier series, where we are learning two forms. One is a trigonometric form of Fourier series. Second one is exponential Fourier series. Two forms of Fourier series we are learning. One is called as a trigonometric form, the other one exponential form. Then we are starting with the different transforms. First transform which we are learning is CTFT, continuous time Fourier. Second one is Laplace. Third one, discrete time Fourier transform. Fourth one, jet transform. Last one, DFT, discrete Fourier transform. All these transforms we are learning. Some of the applications of Fourier transform we are learning, like sampling theorem is one concept. Correlation is another concept. Please don't raise your hand. If you have any clarification in the end of the class, you can ask me. If you raise in the hand in the middle, I will remove it. Please don't do it, sir. Anyone. It's my request. The application topics of Fourier transform we are learning as sampling theorem and concept of correlation, autocorrelation, cross correlation, like that. Apart from this, additional engineering services syllabus is there. This is GATE syllabus. Additional ESC syllabus is digital filter design. where we are learning two forms of filters, IIR, FIR. Fast Fourier transform, which is extension of DFT, we used to have in the GATE syllabus, but they have removed. Only DFT is there, but still FFT is there in ESC. One more advanced topic, speech audio radar signal processing uses. Of course, this topic you can understand only when you are thorough with jet transform, DFT, filter design. If you are thorough with jet transform, DFT and filter design, then only you have a chance of getting this concept. Practical applications of signal subject that we are learning in this speech audio radar signal processing uses. Actually, this year, that is last year, to be free and frank, discrete processing of continuous signals is added as a new topic in EC syllabus. It is nothing but sampling theorem only. Don't get unnecessary emotion for that line. Discrete processing of continuous signal is nothing but sampling theorem only. Okay? So don't be too much emotional towards the topic. As time progresses, you will know. See, sir, in these topics, the basics of the entire subject we are developing in the first chapter only. Basics. To save an example, we are learning a concept called as energy and power signals. That concept again we require in Fourier transform. Energy and power signals, one concept we are learning. That we require in Fourier transform. Another topic like periodic, non-periodic functions that we require in Fourier series. All the fundamentals of the subject we are going to develop in the first chapter only. All the fundamentals of the subject. Don't bother about the number of transforms we have. Once you are thorough with Fourier transform, all other are simple linked topics. Probably some of you are aware, to convert Fourier to Laplace, j omega place we are substituting s. Probably some of you are aware. J omega replaced as s means our Laplace is Fourier is converted to Laplace transform. Of course, there are certain conditions. Blindly, we cannot do that replacement. For instrumentation also, this syllabus as it is. EC and instrumentation, this is the syllabus we have. The weightage. Weightage is GATE exam ECE 9 to 11 marks. Instrumentation around 7 to 9 marks. That is the weightage given. ECE paper 9 to 11, instrumentation 7 to 9 marks. ESC objective, that is prelims exam, 12 to 14 questions will be asked from signals, 12 to 14. Mains exam, they are giving around 60 to 80 marks questions. So the average weightage of signal subject is minimum 9, maximum 11. Those who have written this year paper, you got one question on LTI system property, Parseval's theorem, Plancherol's theorem. As time progresses, you will know all these things. Okay? So try to attend the classes thoroughly. Because it is online session, if you miss some half an hour session, you may not recollect it. Try to attend the classes regularly. Because the first chapter is the most important chapter for learning signal subjects, sir. You must be thorough with introduction, the basics. After developing that fundamentals only, you are in a position to thoroughly attempt the different topics. Okay? So this is the syllabus which we are going to cover. After completion of every slide, To go to the next slide, I will wait for some 30 seconds for you. 20 to 30 seconds. Can we have our contact details? It is not our Mr. Swastik. It is your. Don't be emotional. I'll send. I'll give the data. Wait for a few days. First day, all emotions will be there with you. We are here to serve you. Don't be hurry. 100% I'll give my information. Okay? Don't be hurry. Okay, I'm moving to next slide, sir. What are the books to be followed is reference books. Of course, standard book on signals is Oppenheim Nawab. That is standard textbook on signals. Any other is writing a book on signals means definitely they will copy from this sir. It is standard textbook on signals. Any other is writing a book on signals means definitely they will copy from this. Oppenheim Nawab is standard textbook. We have. But for the first time learner, it will take some time for understanding it. Okay. If you want an easy book to understand, Analog and Digital Signal Processing by Ashok Ambardar. It is like a Chetan Bhagat novel. Very easy presentation on signals. Very easily everyone will understand. You can download this from this site, scribd.com. In that site, it is available. You can download. Don't try to purchase that book. In the Amazon, you may observe it as 9,000 or 10,000. Okay. So it's not easy. Better you can download it. 30% of competitive exam questions are directly asked from this book, sir. The beauty of this book is this fellow, he has explained the concept for 2-3 pages. Every concept will explain for 2-3 pages. Finally, he will conclude what for we have learned the topic in 2-3 lines. He will conclude. That is most important. Review panel. What to remember after learning that much. Okay. The fellows who are not at all having any basics, you can follow this book, Signals and System by Tarun Kumar Rawat. It is from Oxford Publications. He is the copy master. He has copied all best examples at one place from different textbooks. Nothing new this fellow has written. All standard textbooks of signals, this fellow has copied at one place, sir. So for a beginner, it is okay. Okay. Those who are not having any fundamentals, they can refer this. But my suggestion is, whatever I discuss in the class, it is more than sufficient for competitive exams. After writing the exam, you will know. Okay. So listen our discussion carefully. That is sufficient for attempting competitive exam questions. These are standard books. I will follow Oppenheim Nawab. Some topics I will follow BP Lati. Some topics I will follow DSP by Provakis. Different books. It is not possible with you to follow all these books. So better go with this. Ashok Ambardar is one of the excellent book we have. Conceptual. Ashok Ambardar. So many practical examples are also given there. So many. Okay, that is about the reference books. Okay, moving to next slide. Let us start the subject, sir. What is the definition of the word signal? Signal means what? Definition of signal is what? Everyone will say signal contains information. Any physical quantity that is changing has some information. Signal means everyone will say it contains information. But what is information? What is information means randomness is information. Whatever we don't know, from that we are extracting some information that is called as signal, sir. Suppose, for understanding, if you take f of t equals to sin t, the independent variable is time. Every one of us know how to draw it. Means nothing new we are extracting from it. Every one of us know how to draw it. So from this we are not extracting anything new, sir. But if you take a signal like ECG, electrocardiogram, ECG signal, to measure the heart patient beat, generally doctor is checking this graph to measure the heart patient beat. On the y-axis, we are checking the amplitude of heartbeat as the time progresses. Roughly, we are going to observe the graph something like this. When you see this graph, this ECG signal graph, it is random for us. We don't understand anything from that. Why? We are not doctors. Only doctor will recognize that waveform, whether the particular person is healthy or not. So wherever randomness is there, automatically information content also increases. Whatever is random for us, from that we are extracting some information. More randomness carries more information. More randomness carries more information. Whatever we don't know, from that we will extract more information, sir. The less we know, the more we learn. If randomness increases, information content also increases. So without signals knowledge, one easy way to understand this, without signals knowledge, how I am saying that randomness increases the information content. Very funny and easy example I am giving. Don't take serious about it. A dog bites a man. A dog bites a man. Generally, it will happen somewhere. But if it is opposite, if the same statement is opposite, if a man bites a dog, that becomes a breaking news for all our news channels or not. So they will entertain 30 minutes program. So something that is happening randomly provides more information. Something that is happening randomly provides more information. So if our randomness is increasing, information content is also increasing. The fellows who have studied probability, PTSP subject, communication subject, the information in a discrete event we are defining as which relations are? Logarithm of 1 by PA base 2. The information in a discrete event is defined as this. If we select a probability like 1 by 8, how many information bits are needed? 3 bits are needed. But if you take the same probability as 1 by 32, what will be the number of bits? 5 bits. Out of the 2 probabilities we consider, where randomness is more, second case randomness is more. Out of 32 outcomes, 1 is hit. Whereas in the first case, out of 8 outcomes, 1 is hit. Second case, randomness increased. What happens to the number of bits? There is increase in the number of bits. That is what my statement. More randomness carries more information. More randomness carries more information. Every fellow will say signal means information. That is a common statement, sir. But what is the indirect meaning of the word information? If randomness increases, what increases? Information content increases. More randomness carries more information. More randomness carries more information. That is the first property of signal. First characteristic of signal. If randomness increases, information content also increases. The second characteristic of signal is, I am moving to next slide. I am moving to next slide, sir. Second characteristic of signal is, signals are represented as function of one or more independent variables. Signals are represented as function of one or more independent variables. We are using minimum one independent variable or more than one independent variable. The examples like this. If you take voice signal, normal speech signal is one dimensional because the independent variable that is changed is time. When you are speaking with other person, what is a coordinate that is continuously changing? Time. As the time progresses, we are uttering different words. As the time progresses, we are uttering different words. Normal voice signal is one dimensional. If you take an image signal, it is two dimensional because any image signal means it is combination of rectangular grid. Shortcut, it is called as pixel, picture element shortcut pixel. Here, the intensity or brightness is varied with respect to two spatial coordinates. One in the horizontal direction, the other one in the vertical direction. So why image is two dimensional means we have chance of varying two coordinates, two spatial coordinates. Whereas if you take normal TV signal, here the intensity or brightness is varied with respect to two spatial and one time coordinate. So it is three dimensional. Like that, signal is multi-dimensional. For a signal, we can take minimum one independent variable or more than one independent variable. Normal speech signal one dimensional, image is two dimensional, TV signal three dimensional. TV signal is three dimensional. Suppose you want to measure temperature in a locality, sir. If you want to measure the temperature in a particular area, we need four dimensions because we have to take the 3D plane XYZ as well as at what time you want to measure it. So like that, signal is multi-dimensional. We can take minimum one variable or more than one independent variable. Minimum one or more than one independent variable. First characteristic of signal which we mentioned in the last slide is what? Randomness. Now what is the second characteristic of signal? We can take minimum one variable or more than one independent variable. But in signal subject, we are not discussing any multi-dimensional signals. Always on the x-axis, we are changing either time or frequency. Even signal is multi-dimensional, sir. We are not discussing any multi-dimensional signals here. We may take always only one independent variable. It may be time or it may be frequency. One more characteristic of signal is bandwidth. General meaning of bandwidth is it is the range of frequency over which gain is constant. General meaning of the word bandwidth is range of frequency over which gain is constant. Why it should be one of the characteristic of signal is, before transmitting any signal, we have to check what is the channel width to be accommodated. Because we should maintain more channel width or more signal width. Which must be more, sir? Channel width must be more or signal width must be more? If you want to maintain more channel width, first of all, we are in a position to know what must be the signal width or not. Very good. Most of you have answered. Very good. So for that reason, bandwidth is also one of the characteristic of signal. You take any standard signal, we are mentioning some range. Audio, 20 Hz to 20 kHz. Voice signal, intelligibility range is 300 Hz to 3000. So every standard signal we are mentioning some frequency ranges, because before transmitting the signal, we are in a position to know what is the channel width to be accommodated. What is the channel width to be accommodated? So there are three characteristics of signal. First characteristic, randomness. Second characteristic is more than one independent variable. More than one independent variable. Last characteristic is bandwidth. These three are the characteristics of signal. Signal means information. Generally, I will say information means randomness. If randomness increases, information content increases. More randomness carries more information. More randomness carries more information. Okay, moving to next slide. Why we are learning signals in the system subject means before transmitting and receiving any signal, some changes to be made, sir. What are the changes we are making is, first step is enhancing, second step is extracting, third step storing, last step filtering. Before transmitting and receiving any signal, some modifications we are making. Enhancing meaning is amplifying the signal strength. Amplifying the signal strength. Extract means pick the signal. However, voice signal is captured. If you are using a laptop, it can be captured by its microphone. Extract. Storing. If you want to do analysis later on, you are storing the information. So yes, online site is giving chance for you to visit again the online sessions for 2-3 times. So we are storing the information at certain place. If you want to do analysis later on, we are storing that information at certain point. Filtering. To suppress the noise content of the signal, we should design a filter, sir. To suppress the noise content of the signal, we should design a filter or not. So each mathematical step here is a black box. Each mathematical step which I have written is a black box. Enhancing means amplifying the signal strength. Extract means pick the signal. Store the information if you want to do analysis later on. Finally, filter to suppress the noise content. See, once the class is over, they are uploading the PDF file. How they are uploading? First, they will save that information. Later on, in a position to upload it. So we are in a position to watch this content later on also. Correct or not? So all this is done by using some systems. Before transmitting and receiving any signal, we have to make some changes. Each step here is a black box that is called as system. Enhancing means amplifying the signal strength. Extract means pick the signal. Store that information if you want to do analysis later on. Finally, filter to suppress the noise content of the signal. We are designing a filter. Okay, that is the purpose of learning signals and system. Now let us see what are the types of signals we have. What are the types of signals we are having? So I am moving to next slide, sir. What are the types of signals we have? There are three forms of signals. One is called as continuous signal or analog signal. Second one is a discrete signal. Third one is digital signal. Of course, between discrete to digital, we are using a staircase waveform that is named as quantized signal. Discrete to digital conversion, we are using staircase waveform that is called as quantized. So in the strict sense, there are four forms of signals: continuous, discrete, quantized, digital. Why we have four form means, on the y-axis for any signal we are checking amplitude, on the x-axis we are changing time set. On the y-axis amplitude, x-axis time. Amplitude may be continuous or discrete, time may be continuous or discrete. So individually, amplitude and time can be continuous and discrete. Means total how many combinations we are making? 4 combinations. That is what the 4 types of signals: continuous signal, discrete signal, quantized signal, digital signal. What is the definition of continuous signal? Means signal means flow of information. Continuous signal means continuous flow of information. It occurs for continuum values of time. As the time is varied from minus infinity to plus infinity, at every instant we know the amplitude of the signal. It occurs for continuum values of time. It occurs for continuum values of time. That is one style. Another style, a signal which is continuous both in time and amplitude, because we have to speak with y-axis and x-axis. A signal which is continuous both in time and amplitude is called as a continuous signal. Its time is continuous, the respect to amplitude is also continuous. A signal which is continuous both in time and amplitude is called as a continuous signal. Suppose if we have chosen a signal like e power minus 3t ut, what is the graph of this one? It is acting like a decaying exponential. Any signal multiplied by step function means it covers only positive time. It is acting like a decaying exponential. From 0 to infinity, you select any instant, we know the amplitude of the signal. If you want the answer at 2, e power minus 3 into 2. If you want the answer at 4.5, e power minus 3 into 4.5. Time axis continuous, respect to y-axis, amplitude also continuous. Whereas, suppose we have chosen this function. What is the amplitude of y of t at t equals to 1? For yt signal, what is the amplitude at t equals to 1? What is the amplitude of that second signal y of t at t equals to 1? How much? What is the result? Very good. There is change in amplitude from 1 to 2. It is discontinuous at t equals to 1. At 0 also we have a discontinuous amplitude from 0 to 1. At 2 also we have a discontinuity. This type of signals are called as piecewise or discontinuous signals. Piecewise signal or discontinuous signal. At the point of jump location, amplitude is not defined. Wherever there exists a positive jump or negative jump, at that instant amplitude is not defined. So what are the instants here? At 0 we have a raise in the amplitude from 0 to 1. At 1 also we have raise in amplitude from 1 to 2. At 2 there is a drop in the amplitude from 2 to 0. At the point of jump location, amplitude is not defined. The best well-known example for everyone is step functions. Unit step function is discontinuous at origin or not. U of t is also discontinuous at origin. At that instant, amplitude is not defined. So most of the fellows, to show that jump location, they will show the point of discontinuity as a dotted line like this. In the standard books, the point of discontinuity is shown as a dotted line like this. The dotted line indicates what for us? At that instant, change in amplitude has occurred. At that instant, change in amplitude has occurred. At the point of jump location, amplitude is not defined. At the point of jump location, amplitude is not defined. So for the signal y of t, we have three discontinuous instants. 0, 1, 2. At that instant, amplitude is not defined. Rest of the instants, it also has continuous amplitude. Y of t amplitude at 0.6 is 1. What is y of t amplitude at 1.5 means 2. Rest of the instants, this signal also has continuous amplitude, sir. But yt signal has three jump locations. Discontinuity is also called as jump. So what are the jump locations here? 0, 1, 2. At that instant, amplitude is not defined. At that instant, amplitude is not defined. Why continuous signal is also called as analog? Actual word is analogous. Analogous means similarity. In shortcut, we are saying LOG. Analogous means similarity. Why the continuous signal is also called as analog signal means x-axis and y-axis have the same property. Amplitude is continuous, time is continuous. Both variables are continuous variables. Because they are looking like similar, continuous signal is also called as which signal? Analog signal. Analog means similarity. In what way they are similar? Y-axis, x-axis have the same property. Both are continuous variables. Both are continuous variables. So they are interchangeable words. Continuous signal is also called as analog signal. Then what is the definition of this discrete signal? First, it is continuous in amplitude but discrete in time. It means the signal is observed for certain integer values of time index. It is continuous in amplitude but discrete in time. Why do we need a discrete signal means there are two reasons. Why do we need a discrete signal means there are two reasons. First reason, it is impossible to store continuous information directly inside our computer. Because computer can understand logic 1, logic 0. It is impossible to store continuous information directly inside the computer because it can understand logic 1, logic 0. So first, the continuous information must be converted to a convenient form, that is discrete or sampled form. Continuous information must be converted to a convenient form. That is one reason, sir. Second reason, when you take discrete signal, multiplexing becomes very easy. You are aware of mux 4/1, 8/1. Multiple signals are transmitted through single channel. Multiple signals are transmitted through single channel. One reason we are taking discrete signal is for storage purpose. Second reason is the concept of multiplexing becomes easy. Let me explain that point, how the multiplexing becomes easy when you take a discrete signal. To convert continuous signal to discrete signal, we are using a simple switch that is called as a sampler. In the process of converting continuous to discrete, we are using a simple switch that is called as sampler, where T is replaced as NTS. N is any integer value. TS denotes sampling time. N is any integer value. TS denotes sampling time. So practically, what is this sampler means? It is like a switch. We are using switch for on and off. In a similar way, if you want to select the amplitude of the signal, close it. If you don't want to select, open it. It is acting like simple switch. Why the TS comes into picture is, we don't want always uniform separation of one sample. Certain time you want alternation of 3 samples. Certain time you want alternation of 5 samples. That is decided by TS. Based on the gap we want, TS comes into picture. Okay. Let us take, for convenience, for this decaying exponential only, let us observe the discrete equivalent. I am taking same graph, sir. For this decaying exponential only, let us observe the discrete equivalent. xt is e power minus 3t ut means, what is the discrete form? E power minus 3 and ts u of. For verification purpose, I am assuming sampling time as 1 second. X of n is e power minus 3n un. Listen, sir. I'll give 2 minutes time for you for noting down this point. Listen. This is x of t, which is continuous signal. Now we want to take sampled form of the signal. Actually, t is replaced as n into ts, but we assumed n as 1. We assumed n as. Try to check the continuous signal amplitude only at that certain discrete instance. Try to check the continuous amplitude only at that certain discrete instance which we have chosen. What is the amplitude at 0, sir? For original signal, 1. Draw a line of amplitude 1. At t equals to 1, what is amplitude? Because x of t is e power minus 3t ut, at t equals to 1, what is amplitude? E power minus 3. Draw another line of amplitude. At 2, it is e power minus 6. Like that, the respective signal is retained. Like that, the respective signal is retained. What is the difference between xt and x of n? X of t is continuous everywhere, but x of n is considered to be integer, only for integer index. Don't have a wrong thought. X of n is not defined for non-integer values, sir. That is a wrong thought. It is defined, but we are not taking. As I have provided gap of 1 second, we got 0, 1, 2, 3. Suppose the TS, if I assume 0.5, If I assume TS at 0.5, N is multiple of which number? 0.5 or not? Then it is 0 into 0.5, 1 into 0.5, 2 into 0.5, like that. We will not show the TS parameter. Always will show N parameter only. The amplitude of discrete signal between two time instants is just not defined. Don't have a wrong thought, it is 0. That is wrong thought, wrong thinking. The amplitude of discrete time signal between two time instants is just not defined. Okay. So wherever you are observing pinpoint shape, it is like discrete, or lollipop shape, that is discrete. Otherwise, it is continuous. That is the easy way to differentiate continuous and discrete signal. See, sir, one more thing. In our textbooks, if you write x of n, it stands for x of nts. If you write x of n minus 1, originally it stands for x of nts minus ts. Don't have a wrong thought. If you take this notation, we assume ts as 1 second. That is wrong thinking. Probably most of you are aware, to convert continuous to discrete, what is the condition to be satisfied? To convert continuous to discrete, what is the sampling theorem requirement, sir? Sampling rate greater than or equals to 2 times highest analog frequency. Blindly, whatever TS we want, we cannot select it. Okay. So just go through the example. By using a sampler, we are converting continuous to discrete. Please go through the example, everyone. To convert continuous to discrete, T is replaced as N into TS. In the example, we assume TS as 1 second. If you assume TS as 0.5, with 0.5 gap only, you'll get the sample, sir. When you are sampling a signal, it will acquire the continuous signal value at a discrete instance of time. When you are sampling a signal, it will acquire the values from continuous signal only at a discrete instance of time. How multiplexing becomes easy, that point we have to check now. I used a word. When you take a discrete signal, the concept of multiplexing becomes easy. How it is possible, that point we are checking now. Okay, moving to next slide. Let me clarify the point, how the concept of multiplexing becomes easy because of discrete signals. Suppose we entered a word should, and you want to check the graph of that word, sir. After uttering it, you want to check the graph. Any word is combination of phonemes. Nowadays we have voice recorders also. Any word is combination of phonemes. In English we have 42 phonemes. So should word is divided like this, SHOU, like that. Roughly, the graph of SH may be like this. That is sounding like whoosh. So first, what is the discrete form of this one means? T is replaced as N into TS. If you want to take sample form of the signals, T is replaced as N into TS. If you observe those dots, the amplitudes of first 5 samples, which I highlighted with green color pen, the amplitudes of first 5 samples are approximately same. Why to waste our channel width by transmitting the same information? Because from here to here, there is no variation in the amplitude level. From here to here, there is no variation in the amplitude level. Just discard these 4 samples, try to transmit the next sample where it is showing some variation in the amplitude level. How to reduce the number of samples means, for that we are learning a technique called as a decimation. If you want to reduce the number of samples, we need a decimator. If you want to increase the number of samples, we need interpolator. Maybe tomorrow's class you will understand that. So after capturing every signal, if you remove the redundant information, what is the meaning of this word redundant, sir? Even if you discard those, we are not losing anything. By that way, number of samples of discrete signal decreased. If number of samples of the discrete signal is decreased, channel width can be used for more number of signals. If number of samples of discrete signal is reduced, signal width decreases. Signal width decreases means channel width can be used for more number of signals. That is what multiplexing. Our FM radio station, we are tuning to in the range 88 to 108 megahertz. What are the different carrier frequencies? 91.1, 92.7, 93.5 megahertz. When we tune to that frequency, we are in a position to get that particular radio channel. So within that 20 megahertz width, we can accommodate 100 radio stations. All are transmitted through air. That is what multiplexing, transmitting multiple signals through single channel. All signals are transmitted through air. So when we go for a discrete signal, the concept of multiplexing becomes very easy. When we go for a discrete signal. See, sir, suppose a TV fellow has done recording for 3 hours. A particular thing is recorded, but they are minimizing that as 30 minutes program. Whatever is required, that will be shown. Unnecessary data will be removed. Unnecessary data will be removed. When we go for a discrete signal, the concept of multiplexing becomes easy. And one more observation is, every discrete signal is not the sampled form of continuous signal. Every discrete signal we are taking is not obtained just by sampling the continuous signal. Yes, Rohan Kumar. That is what TDM and FDM concept actually. Multiplexing stands for that only. Every discrete signal is not the sampled form of continuous signal. So what is the indirect meaning of the statement, sir? You can have predefined discrete signals. You can have predefined discrete signals like this. If you draw temperature versus time in a particular area, assume for every 1 hour you are taking the readings. Assume there may be rise or drop in the temperature, but it is continuously changing. There may be rise or drop in the temperature, but it is continuously changing, which is directly looking like a discrete signal. It is a predefined discrete signal. Not only that, if you are watching cricket match, we are checking always the number of runs that are scored in every over, like a bar graph like this. They are shown like pillars like this. Number of runs scored in every over, which is shown like a bar graph. It is also a predefined discrete signal. That means you can have predefined discrete signals. You can have predefined discrete signals. The concept of sampling is needed only for multiplexing. The concept of sampling is needed only for multiplexing. Don't have a wrong thought. Whenever we want a discrete signal, compulsory we have to perform sampling, sir. That is wrong thought. We can have predefined discrete signals. Sampling is needed only for multiplexing. Sampling is needed only for multiplexing. Okay, that is the definition of discrete signal. Then what is the definition of digital signal, sir? What is the definition of last one, digital? A signal which is discrete both in time and amplitude. A signal which is discrete both in time and amplitude is a digital signal. Strict sense, it is discrete in time but quantized in amplitude. Strict sense, it is discrete in time but quantized in amplitude. What is the job of a quantizer, sir? It will convert continuous amplitude to discrete amplitude. Suppose at a particular sample, if you got amplitude like 5.6 volts at a particular sample, it may be truncated as 5 volt or round off as 6 volt. It may be truncated as 5 volt or round off as 6 volt. By this process, we are losing some information. That is what quantization error in communication. To reduce that problem, we are increasing the number of levels to reduce that problem. Sampler has done what? Sampler is converting continuous time to discrete time. But amplitude conversion means we need a quantizer. Of course, they are combinedly called as sample and hold circuit. They are combinedly called as sample and hold circuit. Anyway, in signal subject, we need only two forms, continuous and discrete. I am not concentrating anything related to digital here, sir. In communication, you need it. In signal subject, only we have two forms of signals. One is continuous, the other one discrete. Okay. All the explanation which we have done till now, sir. If you observe the block diagram of it, first the continuous signal is passed through an A to D converter. Later on, it is passed through a DSP processor, which is an application specific IC. Finally, it is given to a D to A converter to reproduce our continuous signal back. So we are transmitting continuous, we are receiving continuous. The middle world is discrete and digital. The middle world is discrete and digital. Of course, out of the available converters, you are aware flash type is the fastest one. In flash type, to transmit n bits, how many comparators are needed? 2 power n minus 1 comparator. Each comparator is a 741 IC or not? Each comparator is 741 IC. For audio transmission, minimum we'll use 8 bits. Video transmission means minimum we will use 12 bits. As the number of bits are increased, number of comparators are also increases. Indirectly, cost of that A to D converter increases. This problem is there in the initial days. Nowadays, we are using nanotechnology. It is not a big deal. Okay. You are designing a DSP processor means, depending on the application, it may be an FIR filter or IAR filter. Finite impulse response, infinite impulse response. The main advantage of this system is DSP processors are compatible and reprogrammable. Same processor can be used for multiple applications. Compatible means you are in a position to carry equipment from one place to another place easily, sir. See, our grandfather time, when you want to listen to music, we used to have a gramophone recorder, a black colored LP recorder, long playing recorder is there. A pen recorder is rotating on that. If some dust is there on that, you will not get quality of this answer. Nowadays, we are using iPad. Of course, we have so many apps also. Spotify is one of the app where it can store large amount of information. Audibility is also very good. So compatibility, you cannot carry gramophone recorder from one place to another place easily. You require a separate lorry for that. But we can carry our cell phone very easily in our pocket. So the beauty of digital technology is what? They are compatible. Same processor can be used for multiple applications. So in future, if you do MTech, what you are going to do? MTech signal processing, MTech VLSI, MTech embedded system, what you are going to do? Outside market, design of A to D converter or D to A converter, or it may be DSP processor. If anyone says design a DSP processor means indirectly you are designing an FIR filter or IAR filter. Okay. This is what signal processing block diagram. This is what signal processing block diagram. In all our discussion till now, you remember two things. Continuous signal definition is at any instant of time amplitude is defined. That is continuous signal. Only at certain instants of time amplitude is defined means discrete signal. At any instant amplitude is known means continuous. Only at certain instants amplitude is defined means that is called as discrete signal. These two things you remember, sir. So before discussing further classification, first we'll take all the standard test signals that we are using at one place, which are called as the standard test signals. Which signals are the standard test signals? Step function, ramp signal, impulse, all these are coming under standard test signals or not? Let us discuss all standard signals at one place. I am moving to next slide. The standard test signals which we are discussing is, first one is unit step function. Represented as UT. Represented as U of t. It is 1 for t greater than 0, 0 for t less than. But what is its value at 0, sir? What is the value at 0? It is discontinuous. We have a jump in the amplitude from 0 to 1. Mathematically, u0 is taken as 1 by 2. 1 plus 0 by 2. Mathematically, u0 is taken as 1 by 2. So there is a reason why we are taking that value. Wait for a few minutes, you will get clarity. Why u0 is 1 by 2? Mathematically, u0 is taken as 1 by 2. Where we can observe this type of signal practically? Easy example to give. Starting of any vehicle means indirectly you are applying step function of certain amplitude. Before start of the vehicle, it is in which position, sir? Rest position, amplitude 0. After putting the key in the ignition, when you press the start button, vehicle will start or not? At that instant, there is raised amplitude from 0 to 1. Of course, it is not 1 volt supply, but at that instant, there is raised amplitude from 0 to that required voltage level. Okay. Starting of any automobile means indirectly we are applying step function only. Its application is the transient behavior of any system is checked by applying ut as input. That is what control subject. Rise time, peak time, settling time, all these parameters we are checking by applying ut as input. Its second advantage is it has bounded amplitude. Maximum amplitude of ut is 1. Maximum amplitude of ut is 1. When we are checking the concept of stability, blindly we can apply ut as input. When we are checking concept of stability, sir, blindly we can apply u of t as input. These two are the advantages of taking that as standard signal. These two are the advantages. First signal, unit step function. Second signal, rectangular or gate function. Represented as a rect t by t or a times pi of t by t. Rectangle is a finite length signal which covers from minus t by 2 to t by 2 with amplitude a. So what is the width of the rectangle, sir? Minus t by 2 to plus t by 2 means width is t. That is what this denominator, t by capital T. T by capital T. Some fellows will use the pi symbol also, because if you do slight extension here, it is looking like pi only. The graph is looking like pi. Instead of rect t by t, some fellows will use pi symbol. Any digital signal is always represented as rectangular pulse. Any digital signal is always represented as rectangular pulse. Written to zero coding, non-written to zero coding, communication enjoyment. We are using a rectangular pulse. Ideal form of impulse function is not possible, but it is mathematically approximated version of rectangle. Ideal form of impulse function is not possible, sir, but mathematically it is approximated version of rectangular pulse. Entire Fourier transform chapter, we are going to learn these functions are rectangle in one domain is SAP function or sinc function in another domain. 3-4 days we are learning only on this signal. Rectangle in one domain becomes SAP function or sinc function in another domain. That is the second signal we have. Rectangular function or gate function. Firdaus, it is not only frequency domain. In any domain, if you take rectangular pulse in one domain, other domain it becomes sap function or sync function. Maybe time or maybe frequency, sir. Any domain, no problem. Let me come to that chapter. You will get clarity. Okay. I'm moving to next slide. The third standard signal is continuous impulse, also called as Dirac delta function. Represented as del of t. Del of t. Represented as arrow mark, sir. It is infinity at 0. For all other values of time, it is 0. Del t is infinity at 0. For all other values of time, it is 0. Can you generate practically this type of signal, sir? Is it possible for us to generate this type of signal practically? A signal that is occurring for nullified time but having very large amplitude like infinity. Is it possible? Physical generation of this one? No, but still we are using it. The reason is the mathematical properties of impulse function is making our subject very simple. There are some properties of impulse function because of which we can solve all problems easily. See, when you study network theory, there will assume 1 volt source, 1 ampere source like that. When you study analog subject, ideal op amp we are taking as reference. To start this subject, continuous impulse is reference signal, sir. To start the subject. So what is the correct way of giving this is, it is used as approximation of standard signals. It is used as approximation of standard signals. Impulse means sudden change. A point source, a point charge, a thunderstorm. All these are impulsive signal. Thunderstorm, how much time it will come? Continuously 1 hour. It will occur for a short duration but with a very big sound. Correct or not? So all these are impulsive signals. Listen first, everyone, carefully. Listen first. It can be used as approximation of standard signals. How to understand this point is, suppose we have taken a unit area rectangular pulsar. Area is 1, length into breadth. Area is 1. Go on, compress the time axis, but try to maintain same area. Go on, compress the time axis, but try to maintain same area. If we reduce to minus 1/4 to 1/4, width is 1/2 means height becomes 2. Further compression, minus 1/8 to 1/8, it will go to 4. Like that, when you go on reduce the width of the time axis, what is happening to y-axis, sir? Continuously raising. Continuously raising. For a negligible time, epsilon tends to 0, which may be of the order of 10 power minus 6. Can you visualize 10 power minus 6, sir? No. But 1/10 power minus 6 means very large value or not? That is the reason del t is infinity at t equals to 0. Correctly speaking, t is tending to 0. You are not in a position to define exact origin point for impulse also. We should use the word tending. We may take t equals to 0, but correct word is t is tending to 0. By approximating a unit area rectangular function, what we have generated? By approximating a unit area rectangular function, what we have generated means unit impulse. It is a first property of impulsor. Area or strength of the impulse is 1. By approximating a unit area rectangular function, we generated unit impulse. Practically in the lab, we feel a small 1 microsecond duration rectangle itself, we feel like the physical form of impulsor, because we cannot recognize this gap thoroughly. A small 1 microsecond duration rectangle, we feel like physical form of impulse. Wherever we are using impulse, it is always dealt with area concept, not with amplitude. Don't forget it. Wherever we are using impulsor, it is always dealt with area concept, not with amplitude. If any fellow writes 5 into del of t, sir, on the tip of the impulse, some fellows will show 5. 5 is not amplitude, area. Some signal area is taken as 5 units. That is approximated as impulse. Out of the available signals, impulse is the only signal that is represented by area concept. Area under unit impulse is 1. If you want area of 5 units, you can take. If you want area of 2 units also, we can take. Unit impulse means unit area. Unit impulse means unit area. By approximating a unit area rectangular function, we generated unit impulse. By approximating a unit area rectangular function, we generated unit impulse, which is called as area or strength of the impulse. It need not be rectangle, sir. It need not be rectangle. Suppose we have taken a bell-shaped curve. Everyone knows it is a Gaussian function. E power minus at square general form. Again, go on, compress the time axis. For a negligible time, the graph approaches to impulse shape. For a negligible time, graph approaches to impulse shape. There are so many standard signals that can be approximated to impulse shape. There are so many standard signals that can be approximated to impulse shape. That is the reason the statement used as approximation of standard signals. Second property of impulse is it is an even function of time, sir. Del minus t is del t. Del of minus t equals to del t. It is an even function of time. Because when you rotate with respect to 0, where it lies? At the same instant. If you flip the signal with respect to 0, it lies at the same instant. Impulse is an even function of time. Del minus t equals to del t. It's not a big deal. Rectangle is even function. Gaussian is also even. So we have approximated them to produce impulse. Automatically impulse is also even function. What is the scaling property of impulse? If you want to scale impulse function by alpha units, what will happen to its area? Its area is scaled by 1 by mod alpha. If you want to scale impulse function by alpha units, respective area scaled by 1 by mod alpha. It is modification of first property, sir. What is the first property? Area under unit impulse is 1. Del t place substitute del of alpha t. Del of t place substitute del of alpha t. Assume alpha t as lambda and solve it. Mathematical enjoyment. That will create this tag 1 by mod alpha. When you have del of 3t, what is the answer we have to write? When you have del of 3t, What is the answer we'll write, sir? 1 by 3 times del of t. Del of 3t means 1 by 3 times del of t or not? Like that. Okay. I'm moving to next slide. The next property of impulse is product property. Any signal multiplied by shifted impulse means check the signal at the respective shifter. Any signal multiplied by shifted impulse means check the signal at the respective shifter. Directly t place t naught. X of t naught into del of t minus t naught. Remember theoretically, sir, any signal means xt. Multiplied by shifted impulse means directly we are checking the signal at t place t naught. Substitute that instant. T place t naught. Think of this. Sin t into del of t minus pi by 4. So we have to check the sine function at which instant? Pi by 4. Sin pi by 4 is how much? Sin pi by 4 is how much? 1 by root 2. Directly check the signal at the respective instant. Directly check the signal at the respective instants. Now your response are 3t plus 5 into del of t. What you can say? 3t plus 5 into del of t. What is the result? Right side. Impulse existed 0. So directly in the signal t place 0 or not? Very good. Most of you responded. 3t plus 5 into del of t means replace there. 5 into del of t. Xt into del of t minus 1. X of the graph also I have given. Just tell me amplitude sufficient. Xt into del of t minus 1, sir. What will be the amplitude? Very good. For 2 units, it is 4. You wanted 1 means what will be the amplitude? 2. For 2 units, amplitude is 4 means 1 unit it is 2. 2 into del of t minus 1. Okay. The next property which we are taking is called as sampling or shifting property. Integral of xt into del of t minus t naught equals to x of t naught. Shift should lie within the limits. If the given signal is continuous at t equals to t naught, that is the correct answer, sir. Same answer becomes 1 by 2 times of x of t naught if xt is discontinuous at t naught equals to t1 and t naught equals to t2. If the signal has a jump exactly at the shift value t1, t2, then it is 1 by 2 times. Otherwise, simply x of t naught. Otherwise, simply x of t naught. Of course, we got this property from our last property only, sir. From last property only we got it. What is the last property? X of t into del of t minus t naught is this. Apply integral both sides. When you apply integral both sides, right side x of t naught is some fixed value. Area under impulse function is 1. Even it is shifted, area remains same. Even it is shifted, area remains same. Product property is modified to sampling or shifting. If our signal is continuous at the shifter, T1 and T2 both are included. Some funny questions will be asked from this property in different exams, sir. Very easy questions like this. Suppose we want this integral. Tell me the answer. Integral minus 1 to 3 t plus t square del of t minus 5. What is the result? Very good. First, we have to check the location of impulse. Where our impulse exists, sir? Where is the impulse? At 5. Limits of integration are outside. So the result is what? 0. Impulse function outside the limits. Answer is 0. Think of this. 0 to infinity t plus cos pi t into del of t minus 2. 0 to infinity t plus cos pi t into del of t minus 2. Very good. Good response. Very good. Now, impulse is within the limits or outside the limits, sir? Within the limits. Directly substitute that instant. That is 2 plus cos 2 pi. Of course, it becomes 3. 2 plus cos 2 pi. Directly substitute that instant because it is within the limits. Think of this. Integral of y of 5 minus t into del of 3 minus t dt. integral of y of 5 minus t into del of 3 minus t dt. What will happen? As impulse is even function, we stated del minus t equals to del t. As impulse is even function, this can be written as t minus 3. 3 minus t or t minus 3 means same. So it is at 3. Directly substitute in the signal y of 5 minus 3. That is y2. That is now you think of integral of t square del of minus t by 2 plus 1 by 2 dt. Now the impulse contains scaling term. Be careful. It is not del t, del of alpha t forms are. Be careful. What is the result? Very good. Very good. So if I take minus 1 by 2 common, t minus 1, del of alpha t relation is what, sir? 1 by mod alpha del of t. Del of alpha t can be written as 1 by mod alpha del of. So shift is within the limits 2 into 1 square. Answer is 2. Last two properties of impulse we will use multiple times in our discussions, sir. Last two properties. That is product property as well as sampling or shifting property. Both properties will use multiple times. So be careful. Rudras. Okay, that is about impulse function and its different properties. Impulse function and its different properties. Next, we are taking ramp function. Ramp signal R of t. A simple straight line. Best practical example of ramp signal is daily stock market. Share value may be increased by this many points or dropped by this many points. Daily stock market is the best example for ramp sir. Or when a target is moving at a constant velocity. When a target is moving at a constant velocity, a tracking antenna may be needed in order to track the plane. That is like a ramp function only. Can you tell me what is differentiation of these functions there? Differentiation of ramp is step function. Differentiation of ramp is step function. So if you take one more derivative at the point of jump location, an impulse. Differentiation of straight line is constant. Differentiation of constant is at the point of discontinuity and impulse. Everyone listen this point carefully, sir. Everyone. There are two things to be observed. In the strict sense, ramp function at 0 is not 0 in the strict sense. The reason, if ramp function amplitude at 0 is 0, step function must be 0, sir. If ramp function at 0 is 0, step function must be 0. That is not happening. So in the strict sense, ramp function at 0 is not 0. One more thing is, mathematically we will say differentiation of step function is impulse. Opposite way, unit step is integration of impulse. In the correct sense, this is also wrong formula. The reason is, when u of t is discontinuous at origin, according to general maths, we cannot differentiate a discontinuous function. We know clearly ut is discontinuous at origin. We cannot differentiate a discontinuous function, but still we will use that as a valid formula. The reason is, ut will never start exactly on the y-axis. It will start with a bend, sir. Unless otherwise you are not observing thoroughly, you cannot recognize. You take your hand in very straight manner, slightly bend it. So ut will also bend like that. So 0 to epsilon portion, roughly it is looking like ramp. 0 to epsilon, that is very small, 10 power minus 3, negligible. So 0 to epsilon ramp segment, if you differentiate, you are getting constant. So this is the physical form of impulse. This is the physical form of impulse. As epsilon is a negligible number, we feel it is correct formula. As epsilon is a negligible number, we feel it is correct formula. Two things we observed here. Strict sense, ramp function at 0 is not 0. Mathematically, this is wrong formula. Still we are using it because ut is discontinuous at origin, but we cannot differentiate discontinuous function. ut will never start exactly on the y-axis. It will start with a bent. A slight slope will be there. Okay. Some fellows in the textbooks, they will call this as running integral, because integration limits are varied from minus infinity to t. They will use the word running integral. Nowhere it is running. The name is like that, running integral. Integral limits are from minus infinity to t, sir. Okay. Can you tell me what is the meaning of the word singularity function, sir? What does it mean? Singularity function means what? The functions which are not having higher order derivatives. The functions which are not having higher order derivatives are called as singularity functions. Example, step and ramp. Unit step function, we have only one derivative. Ramp signal has two derivatives. The functions which are not having higher derivatives. Higher derivatives means even 10 derivatives also finite. They should have practical significance, sir. So ut and ramp, they are considered to be singularity functions. The other way to say, most of you are good in Laplace. Ut Laplace 1 by s, ramp signal Laplace 1 by s square. Both signals have poles at origin or not? Both signals have poles at origin. So singularity functions are the functions where they can have their poles at origin. Singularity functions are the functions where they can have poles at origin. That is other way of saying it. Of course, from ramp signal only we are forming triangular functions represented as a tri of t. Represented as a tri of t. It extends from -1 to 1 with amplitude 1. We are fixing the width of the triangle as 2 units to make area as 1. We are fixing the width as 2 units to make area as 1. Half base height. Half base height. Don't be in confusion with rect t, sir. Rect t covers from -half to half. Here also area is 1 only, length into breadth. But tri t is not covering from -half to half, where it covers -1 to 1. Tri t covers from -1 to. Don't have a confusion between rectangle and triangle. Rect t covers from -half to half. Tri t covers from -1 to 1, not -half to half. Unit area, like unit impulse, we are feeling unit area as reference. So we are fixing its width as 2 to make area 1. Okay. I'm moving to next slide, sir. The next standard signal which we are taking is called as signum function. SGN of t. Signum. SGN of t. It is a bipolar signal that is having 2 amplitude levels. Bipolarity means 2 amplitude levels. Positive time +1, negative time -1, sir. It is a bipolar signal that is maintaining 2 amplitude levels. Positive time +1, negative time -1. Can you tell what is the value at origin? What is signum function value at origin, sir? Actually, it is discontinuous. We have a jump in the level from -1 to 1, but average value 0. If you take average, 1 minus 1 by 2 is 0. Actually, it is discontinuous. Signum function is a odd signal. Signum function is a odd signal. For any odd signal, the amplitude is 0 at origin. It is a standard property. Signum function is odd signal or antisymmetric, sir. For any odd signal, the amplitude is 0 at origin. Standard property. What is sin t amplitude at origin? Sin function amplitude at origin also 0. Any odd signal, the amplitude is 0 at origin. Standard property. No one can change it. How to write this signum in terms of step function? Let us see. Upper graph is ut. What is the folded version of that one? If you flip it, it is u minus t. Do amplitude scaling. That is minus u of. So signum in terms of step function is ut added to minus u of minus t, or purely in terms of ut 2 ut minus 1, or purely in terms of ut 2 into ut minus 1, sir. First expression visible from the graph. Let us observe how we got second one. If I take one for all time, sir, positive time it is ut, negative time it is u minus t or not. Positive time the graph is ut, sir. Negative time u minus t. If I take both the signals separately, if I draw ut and u minus t separately, at which instant they are facing the problem? Ut has discontinuity at origin. U minus t also has discontinuity at origin. Ut has discontinuity at 0. U minus t has discontinuity at 0. Everyone recollect? In the beginning, what is u0 number we have taken? In the beginning, mathematical number u0, how much, sir? 1 by 2. So u0 plus u0, 1 by 2 plus 1 by 2 becomes 1. 1 by 2 plus 1 by 2 becomes 1. To satisfy this general expression only, we have taken u0 1 by 2, no other reason. 1 for all time can be written as positive time ut, negative time u minus t, sir. When you draw the signal separately, ut has discontinuity at origin, u minus t has discontinuity at origin. Mathematically, u0 1 by 2. Why? u0 plus u0, when both are added, we have to produce 1 as the result. So don't eat my brain later on for this point. I have given clarity. To obey this expression, we have chosen u0 1 by 2. No other reason is there. Okay. Anyway, from this expression, u minus t is 1 minus u of t. Just replace here. Directly u minus t place, if you substitute 1 minus ut, we are getting second term or not? 2 into ut minus 1. For signum function, two formulas are correct, sir. One formula ut minus u minus t, another formula 2 ut minus 1. One more point we checked here is what? For any odd signal, the amplitude is 0 at origin. For any odd signal, amplitude is 0 at origin. Take a short break for 20 minutes. Again, I will continue. Take a short break for 20 minutes, everyone. We'll continue again, sir. Okay, let us continue. The last function which we studied is signum. It is a bipolar signal which is maintaining two different amplitude levels. Positive time +1, negative time -1. Next form which we are discussing is different forms of exponentials. Different forms of exponentials. First one is called as a real exponential, represented as e power sigma t, where sigma is a real number, e power sigma. Suppose we selected e power -2t, it is acting like a decaying exponential. Or if you take e power 4t, it is like a growing or increasing exponential. So the first form of exponential is real exponential. Second form is complex sinusoids, e power ± j omega naught t. Complex sinusoid, e power ± j omega naught. Of course, it is Euler's identity. E power j theta expansion is cos theta ± j sin theta. Cos theta ± j sin theta. Third form is complex exponential, represented as e power st, sc sigma plus j omega. It will have a real component as well as imaginary component. Sum of first two is the last one, complex exponential. Generally, complex sinusoids are used for Fourier series, Fourier transform. This is used for Laplace. Physical generation of complex signals are not possible, but still they are used. Physical generation of complex signals are not possible, but still they are used because of their mathematical convenience. You perform any mathematical operation on them, they will reproduce the same answer. Suppose you are differentiating e power j omega naught t. What will be the answer? J omega naught multiplied by that exponential. If we are integrating it, again same answer divided by j omega naught. If you are taking delay, then also the answer is same. You perform any mathematical operation on them, they will reproduce the same result. That is what generally we are studying as eigenfunction in signal subject. Eigenfunction. Whenever the input and output forms are same, they are treated as eigenfunction. So which are the standard eigenfunctions we have in signal subject is exponentials. Complex sinusoids and complex exponentials are eigenfunctions of LTI system. Whenever the input and output answers are same, they are treated as eigenfunction. Whenever the input and output form are same. You perform any mathematical operation on them, they will reproduce the same results. Decaying exponential, you are aware, charging or discharging of a capacitor is in RC circuits is looking like a decaying or growing type of exponential or not. Charging or discharging of a capacitor in practical RC circuits. These are some of the standard continuous signals which we are using in the subject. some of the standard continuous signals. Till now, we have taken all signals with respect to the independent variable time, sir. X-axis time. All signals we have drawn with respect to the independent variable as time. But if a question is asked, like draw one function in terms of another function, draw one function in terms of another function, how to sketch it? Let us observe in the next slide. Suppose it is asked to draw the graph of u of sin t. Think and respond. Like ut, it is given as u of sin t, sir. Instead of ut, it is given as u of sin t. How to draw the graph? Compare with ut definition. You are going to decide the result. So it is 1 for sin t greater than 0, 0 for sin t less than t plus sin t is given. By taking sine wave as reference, we are going to sketch the signal, sir. Normal sin t is like this. So u of sin t means from the mathematical expression, how to draw u of sin t, sir? Sin t greater than 0 means for a positive half cycle of sine wave, for that interval, the new amplitude is 1. So 0 to pi range. Sin t less than 0 indicates negative half cycle of sine wave, its amplitude is 0. For all positive half cycles, it is 1. For all negative half cycles, it is 0. All positive half cycles 1. All negative half cycles, it is 0. Sin t less than 0 indicates whenever sine function has negative amplitude, for that interval it is 0. Don't have a wrong thought. If it is u of sin t, why we have drawn the signal for negative time? The shape of this function is decided by sin t, not by ut, sir. As sin t is infinite length, u of sin t is also infinite length. Can you tell me what is the change for signum of sin t? What is the change in the graph for signum of sin t, sir? Signum function nature is constant amplitude. Positive time 1 for sin t greater than 0. Minus 1 for sin t less than 0. Again, with respect to this sine wave as reference, with respect to sine wave as reference, what will happen now? All positive half cycle of sine wave plus 1 negative half cycle of sine wave -1. All positive half cycles we are taking +1, negative half cycles minus. Think of del of sin t similar way in comparison with impulse definition. Del of sin t. We know del t is infinity for t equals to 0. That means sin t equals to 0. What is the general solution of sin t, sir? Integer multiples of pi. Integer multiples of. So what is the graph now? We are taking stream of impulses which are occurring for integer multiples of pi. Which are occurring for integer multiples of. All the three signals are looking like periodic functions or not. Which we have drawn on the board, all they are looking like periodic functions are. We have repetition of the same pattern. So they are looking like periodic functions. So whenever one function is asked in terms of another function, don't be panic. First you draw the bracket term, which is reference. First you draw the bracket term as reference. Later on we can sketch the new signal. Okay. I am discussing the next concept. The next concept which we are observing is transformations of the signal. Transformation means how one can modify a given signal with respect to the independent variable time, sir. How one can modify a given signal with respect to the independent variable time. That is called as transformation. The first change which we are making is called as a time scaling. If xt is the continuous signal, scaled form is represented as x of at. If xn is the discrete signal, x of mn is the scaled form. First operation is time scaling, sir. Second operation is time shifting. Continuous case t minus t naught. Discrete case n minus n naught. Third operation is reversal. Time reversal. X minus t or x of minus n. The last operation is amplitude scaling. If you want to change the y-axis, That is called as amplitude scaling, k into xt or k into x of n. In real-time applications, somewhere we require one of the property, everyday life, time scaling, time shifting, time reversal, amplitude scaling. To give some examples, sir, if x of t is like tape recording at certain speed, y RPM, assume it is like a 60 minutes cassette, y revolutions per minute. If it is like 60 minutes cassette, sir, x of 2t indicates same recording at twice the speed. As we increase the speed, recording can be completed in half time, 30 minutes sufficient. As we increase the speed, x of t by 2 indicates same recording at reduced speed. So the concept of speeding up or speeding down is linked to scaling principle. Concept of speeding up or speeding down. Certain times, whenever we are checking our images, JPEG images, we are using zoom in and zoom out tool, where the original size may be 8 by 8, but that can be modified as 16 by 16, 32 by 32, depending on the requirement. That is called as spatial scaling, sir. That is called as spatial scaling. Where we require shifting. Nowadays, we are transmitting the telephone calls by using satellite. The minimum amount of time we require to transmit and receive any call is 540 milliseconds, sir. Nowadays, we are transmitting the telephone calls by using satellite. The minimum amount of time we require to transmit and receive is 540 milliseconds. Actually, now you are attending online session. If my signal is XT, whatever you are receiving is the shifted version. Generally, the amount of delay is 40 seconds to 50 seconds. If I am saying something to you, it is audible to you with that much gap, 40 to 50 seconds gap. Okay. Where we require reversal means playing the CD in the reverse direction. If you are listening to some audio CD, which has some number of songs, if you want to listen one more time, just we are using rewind button. See, sir, signal processing is done with the 3 operations: real time, online, non-real time, offline. Certain times it is combination of both, real time plus non-real time. That is called as hybrid. Now the class is going on, that is real time. Just now the work is started, it is continued, that is real time. Non-real time means after 2 or 3 days, if you watch the videos that are uploaded, that is called as non-real time. What is hybrid? Before 2 or 3 days, some experiment was started, still we did not get the output. Hybrid means combination of real time and non-real time. Before 2 or 3 days, some experiment was started, sir. Still we did not get the output. That is called as hybrid. Time reversal comes under non-real time operation. In real time, there is no meaning for negative value. So time reversal comes under non-real time. Certain times you may change the y-axis. That is called as amplitude scaling. If I take k value greater than 1, that is called as amplification. If you take k value less than 1, that is called as attenuation. Certain times, if you want to change the y-axis, that is called as amplitude scaling. Another example to say, assume radar is tracking the position of aeroplane, sir. Radar is tracking the position of aeroplane. At different instants of time, it is at different elevation angles. From the ground station, some signal is transmitted, that is like XT. From the pilot back to the station, we are receiving some amount of information which may be shifted version of original one. There may be scaling in its amplitude. Due to atmospheric disturbances, noise component may be added. So what are the two things here? Change in amplitude as well as certain amount of delay. At higher distances, strength of the signal will decrease. If you go to a hilly area, do we get cell phone signal properly? If we go to a hilly area, sir, do we get cell phone signal properly? At higher distances, strength of the signal will decrease. Like that, there are multiple applications for these transformations. I explained few examples for you. In everyday life, somewhere we require one of the property. But now we have to check how these operations are done mathematically. How these operations are done mathematically. I'll come back to this slide. Wait for a while. I'll come back to this slide. Suppose if we have taken a rectangle from -1 to 1, sir, tell me how to get x of 3t and x of t by 5. It means first time we are checking which principle? Which principle we are checking? Time scaling principle. Time scaling. So x of t is 1 for the interval -1 to 1. What is the meaning of x of 3t, sir? It is 1 for -1 less than 3t less than 1. Here solve for time. -1/3 less than t less than. So the signal x of 3t covers for what length? -1/3 to 1/3 having amplitude of 1. X of 3t covers for the length -1/3 to 1/3 with amplitude of 1. What is the length of the original signal, sir? Everyone see here. What is the length of the original signal? 2 units. But what is the length of new signal? 2/3. Means it is compressed or expanded. The original signal length decreased by 3 units. X of at form a greater than 1 is called as compression of xt. X of at form a greater than 1 is called as compression of x of t. Without all the stupid maths, how to draw x of 3t is multiplication here becomes division in the time axis. We want x of 3t directly perform division by 3 here, sir, for the rectangle. That is -1/3 to 1/3. In a similar way, what is x of t by 5? Division here becomes what there? When you are dividing by 5, there it becomes what, sir? Multiplication. Same rectangle extends from -5 to 5. What is a value now? 1/5 means it is less than 1 greater than 0. X of at form a 1/5 less than 1 greater than 0. It becomes expansion of x of t. That is the point of observation. X of at form a greater than 1 is compression. A less than 1 positive is expansion. That is the first operation, time scaling operation. Okay. Please refer this slide first. The different transformations now we are learning is first operation scaling, sir. Array counter instrumentation IN. For fun, I am discussing. Otherwise, if they don't ask transformation, if possible, meet me. I will tell you. If you are from Hyderabad, meet me. Without scaling, shifting, reversal, what you will do? Dancing, huh? Convolution chapter requires it. Fourier transform requires it. Without knowing them, what you will do? I'm teaching the subject from 20 years. What questions we will get in the exam also, I will know that models. So don't be emotional. Listen my class thoroughly. I'm not saying I'm great, but whatever I discuss, that models will appear in the exam. So just concentrate on it, sir. Don't deviate for other things. So total 4 operations we have to learn: time scaling, shifting, reversal, amplitude scaling. First we started with this one, sir. Simple example. With a simple example, we started with scaling. X of AT form A greater than 1 compression, A less than 1 positive is called as expansion. Okay. Let us see shifting operation for the same graph, sir. Let us see. Suppose for the same signal, if we want these two, of course, our original signal covers from -1 to 1. It means now we are checking shifting operation. X of t minus t naught form, t naught is +4 and -3 respectively. X of t minus t naught form, t naught positive, t naught negative. Our symbol is what, sir? How we represented shifting? X of t minus t naught. Shifting means the thought you should get in your mind. T minus t naught is our symbol. First time t naught +4, t naught -3. Whatever the shift we have, add to the time axis, sir. First time shift is 4, add 4 there, such that where the rectangle covers, it extends from 3 to 5. 4 minus 1, 4 plus 1. So that is looking like right shifter, left shifter. T minus T naught form, T naught positive means right shifter, left shift, sir. Signal is right shifted. Original signal right shifted by 4 units. Original signal right shifted by 4 units. If you add -3, second guess, sir, where the rectangle extends. If you add -3 there, it extends from -4 to -2. So now the shift is negative. It corresponds to left shift. T minus T naught form, T naught negative, it corresponds to left shift. T naught positive, right shift, T naught negative, left shift. Taking negative T naught is called as a time advancer. It is not coming under real time operation. Non-real time only. Why it is non-real time means at which instant x of t started, sir? -1, but the shifted signal starts at -4. If you apply input at 9 o'clock, will you get the output at 6 o'clock? If you apply input at 9 o'clock, will you get the output at 6 o'clock? Before giving input, output is possible means non-real time. Already the data is stored. Already the data is stored. Positive T naught is called as a time delay. Negative T naught is called as a time advance. Time advance is a non-real time operation. Positive T naught, time delay. Negative T naught is time advance. Time advance is a non-real time operation. Of course, the last operation is x minus t, meaning is rotate the signal with respect to y-axis, or simple way, flip the signal. If you rotate the signal with respect to y-axis, you will get right side portion on left side portion on the right side. Luckily, already we have taken symmetrical function, so the answer remains same. Time reversal meaning is rotate the signal with respect to y-axis. Joseph, that is what I said now. Left shift is not real time. For that only I have given example also. If you apply input at 9 o'clock, will you get the output at 6 o'clock? Before giving input, output is not possible. If it is possible means you have stored that data somewhere. If you store the data, you can take advanced instance. That is not a big matter. Once today's class is uploaded, tomorrow or day after tomorrow, you can see advanced class also, because already the data is stored for you. That is non-real time. So wherever we are using these three operations, we will never violate those conditions, sir. Time scaling symbol is what? X of AT, A greater than 1 compression, A less than 1 positive is expansion. Shifting symbol is what? T minus T naught. T naught positive is right shift, T naught negative left shift. Last one is reversal. Flipping the signal, rotate the signal with respect to y-axis, which is also called as flipping, like flip the coin. Rotate the signal with respect to y-axis. In this simple problem, we have done these operations separately. Simple problem. But how to perform them combinedly? If a problem contains scaling shifting or reversal scaling shifting, how to perform them combinedly? So let us take a fresh problem on that, sir. Listen carefully. Let's take a fresh example. Suppose if a signal is given like this, tell me how to generate this combination of signals. You draw one by one. No need to write all the expressions. Draw one by one. Make a try. Those who are solving along with me, make a try. X of t we selected like a piecewise signal. For different intervals, its amplitude is different. How to generate these different combination of signals? First one is direct right shift or not. First signal graph we are expecting is x of t minus 6 with t naught positive. T naught positive means what, sir? Directly right shift of 6 units to the existing time axis. Add 6. If you add 6, where it covers? 6 minus 1 to 6 plus 7. Directly right shift of 6 units. At every discontinuous instant, add 6, 6 minus 1, 6 plus 2. Second bit includes both scaling and shifting. X of 2t plus 1 we want, sir. It includes both scaling and shifting. How to get if it involves both operations? First scaling, then shifting we have to do, or first shifting, then scaling we have to do. Means both are valid methods. To generate x of alpha t plus beta form, there are two methods to answer it, sir. First method, take alpha common internally, it becomes t plus beta by alpha. Take alpha common internally, it becomes t plus beta by. So first operation is x of alpha t, that is time scaling. Second operation is, depending on beta by alpha, it may be right or left shift. First, once you separate out alpha, automatically first step is scaling, sir. Once you separate out alpha, first scaling. Later on, that signal is shifted. This is one method. Second method is, take x of t, immediately t plus beta, that is time shifting. Later on, go for scaling. T is replaced as alpha t. T is replaced as. Once you shift the signal, later on scale it. Okay. Both techniques will produce same result. You follow any method, result is same, sir. I am habituated to first method. I will follow it. If you are good with second method, follow it. Both techniques will produce same answer for us. For your understanding, 1 or 2 bits I will explain both the methods for your understanding. But I am habituated to first technique, sir. I will always do scaling, then shifting. Okay. Okay. Let us get x of 2t plus 1 by first approach. Internally, if you take 2 multiplier common, it is 2 into t plus half. First, we are scaling by 2 units. Later on, t minus t naught symbol with t naught minus half. With t naught minus half. So, first time scaling, that is x of 2t. Shift the scaled signal left by minus half. After getting x of 2t, shift the scaled signal left by minus half. T naught negative, sir. So what is the meaning of x of 2t, sir? Compressed or expanded? In the original signal, at every discontinuous instant divided by 2. In the original signal, at every discontinuous instant divided by 2. The signal graph remains same. Perform division by 2. That is x of 2t. At every discontinuous instant divided by 2. Later, what we are doing, sir? Shift the scaled signal left by minus half. To the time x of 2t, add minus 1 by 2. To the time x of 2t, add minus 1 by 2. directly to the time axis of x of 2t at minus 1 by 2. So this is the graph. What is the alternative way of getting the results, sir? Take x of t. First, it must be shifted. Later on, t is replaced as 2t. Take x of t. First, it is left shifted. Later on, replaced as 2t. X of t plus 1 meaning is left shift of 1 unit. So to the time axis of xt, if you add minus 1, sir, to the time axis of x of t, if you add minus 1, where the graph covers minus 2 to, that is x of t plus 1, I am naming as yt. That is x of t plus 1, I am naming as yt. Immediately you want y of 2t. So what will happen? Compression or not? At every discontinuous instant divided by divided by 2. So see the green tick mark, both sides are, graphs are same or different. First scaling, then shifting, or first shifting, then scaling. We got same graphs or different graphs. Left side I followed first scaling, then shifting. Right side first shifting, then scaling. Result is same. So it depends on your idea how to approach the question. Both ways the result is same. Scaling, shifting we can do. Shifting, scaling also we can do. Okay. What is the third signal expected is x of 5 minus t. Make a try, sir. Everyone. X of 5 minus t. Make a try. If we go by first method, internally minus 1 common scaling factor. So x minus t means time reversal. Here t naught positive. Shift x minus t right by 5 units. Shift x minus t right by 5 units. So what is x of minus t meaning, sir? If you rotate with respect to y-axis, this triangular segment on the right side, this complete portion on the left side. So x minus t graph is going to appear like this. If you rotate with respect to y-axis, flip the signal with respect to y-axis. Flip the signal with respect to y-axis. The easiest way to recognize time reversal in your notes is, everyone observe x of t graph thoroughly, sir. Very deeply you observe x of t and turn the page. Observe the image of xt. After looking at x of t very thoroughly, just turn the page and observe the image of xt. That will look like x minus t or not. What, bachas? First look at xt. Just turn the page, sir. Observe the image of xt. That will look like x minus t. That is what rotating with respect to y-axis. What is y-axis for you in your notes? Just turn the page. Turn the page and observe the image of xt. That is x minus t for us. The second step here is shift the time reversal signal right by how many units? 5 units. To the time axis, if you are adding 5, to the time axis of x minus t, if you are adding 5, what will happen? It covers from 3 to 6. First reverse, then right shift we have done. What is alternative style? That way also everyone check. Just for idea. Take x of t plus 5. Then you reverse it. X of t plus 5 meaning is t naught negative minus 5. Try to shift x of t left by 5 units. If I shift left by 5 units, here, to the time axis we are adding minus 5. So where the shape will cover, sir? This is x of t plus 5. Immediately we want reversal of that. If you take reversal of that, it will appear like this. This one again, they are same or not? Again they are same. Left side we have done scaling, then shifting. Right side shifting, then scaling. Of course, the answer is same. What is the fourth one asked here? X minus t minus 2. Carry on. X of minus t minus 2 we require. It is nothing but x of minus of t plus 2. I am following my style. First method, sir. Already x minus t is available for us. Take left shift of 2 units. Already x minus t is available. Take left shift of 2 units. So where it covers, if you add minus 2 here, x minus t signal left shifted by 2 units. It means to the time axis we are adding minus 2. To the time axis we are adding minus 2. Everyone, please try the last combination of this problem, sir. Xt plus x minus t into ut. That is the last combination. Xt added to x minus t. Overall signal multiplied by step function. Any signal multiplied by step function means what does it mean? We want resultant signal only for positive time. We want resultant signal only for positive time. Carry on. Make a try. Xt plus x minus t multiplied by ut. This is x of t. For that we are adding the folded signal we want resultant signal for positive time, so I am not concentrating the shape for negative time. No need to cancel from your side, sir. I am not concentrating for negative time. Some shape will be there, don't bother. So for positive time, how many discontinuous intervals are there? If you concentrate only for positive time, how many discontinuous intervals are there? 0 to 1, one interval, 1 to 2, another interval. 0 to 1 ramp signal added to constant means ramp function amplitude raised by that many units. Ramp plus constant means ramp amplitude raised by that many units. At 0, here amplitude is 1, here also it is 1. 1 plus 1 becomes 2. Here it is 1, here also it is 1. 1 plus 1 becomes 2. At 1, here it is 0. Actually, this is discontinuous, sir. Assume 1. Actually, it is discontinuous. Assume 1. We'll take discontinuity for next interval. For the interval 0 to 1, ramp added to constant means ramp function amplitude raised by that many units. 1 to 2, here some shape, here nothing means that shape is retained as it is. 1 to 2, here some shape, here nothing means shape is retained as it is. That is the resultant graph. For the interval 0 to 1, ramp signal added to constant means ramp function amplitude raised by that many units. Ramp function amplitude raised by that many units. Suppose in the same problem, if I am expecting the signals are, what are the sequence of steps to be followed? Only tell me sequence of steps. Our style is alpha t plus beta. Never forget it. That is a general form. So internally, minus 1 by 5 common. So it becomes t minus 15. First take xt, reverse x minus t, scale by 1 by 5 means x of minus t by 5. First take xt, reverse, scale by 1 by 5. Later on, right shift by how many units are? 15 units to get the overall graph. Later on, right shift of 15 units to get the overall graph. Take xt, reverse it, scale by 1 by 5. Later on, right shift of 15 units. Most of the fellows will discuss second method in different colleges, shifting then scaling, not the first approach. The reason for that is, suppose we are expecting x of 2n plus 3, sir, discrete case, assume. Suppose we are expecting x of 2n plus 3. If I want to follow our first method, 2 is the common multiplier, scaling factor 2. We can scale the signal by 2 samples, that is okay. But what is n naught number we are getting, sir? Discrete case minus 1.5 sample, which is meaningless. Why? Discrete signal is defined only for integer index or not. If you take 2 common, no problem, 2 into n plus 3 by 2. We can scale by 2, but expected shift is minus 3 by 2, meaningless. Non-integer shift we cannot take. To avoid this problem, most of the fellows will enjoy second method only, first shifting then scaling. But we solved continuous problem till now. We have not faced anything. Scaling, shifting or shifting, scaling, they have produced same result. I will ask this question in reverse way, try to answer it. In this problem, I have given XT, I want scaled and shifted version. Now I will give scaled and shifted version, you tell me original signal. Okay? Make a try, everyone, be ready. Reverse way, I will frame the question, answer me. Consider y of t equals to one by 5 times x of minus 3t minus 1 shown below. That fellow has given y of t, sir. Question is draw x of t. Tell me what is xt graph. Directly scaled and shifted form is given. We want original signal. One clarity every fellow is having is time scaling and time shifting are affecting only the time axis, not the shape. Time scaling and time shifting are affecting only time axis, not the shape. Shape as it is only. So think of tell me the time axis of x of t. I want only time axis. For what time x of t should be there originally? Respond in the chat box. I want time x of t. Are you there or sleeping or trying the problem? For what interval x of t covers, that you tell me sufficient. Baru Prakash, you are nearer to the answer, but somewhere you have done mistake. Check it. Dinakar, correct. Shivam, also correct. Arey bachas, only two fellows are. Divya also correct. The simple thought we need is, as time scaling and time shifting are affecting only time axis, don't check for inverse operations, sir. Taking minus 3 common, what is y of t plus 1 by 3 like that. At which instance y of t is changing its nature? 0, 1, 3 in the graph. I am assuming the bracket term like alpha x of t style. If t is 0, alpha minus 1, t value 0. If t is 1, alpha becomes minus 4. If t is 3, it becomes minus 10. Assume this bracket term as x of alpha style, x of t. At that instance, the respective signal x of t is changing its nature. When you look at the graph 0 to 1, here we have RAM. But for original signal, it is there for which interval? Minus 1 to minus 4. 1 to 3 constant. For original signal, it is there from minus 10 to minus 4. We should take amplitude as 5 because 1 by 5 into 5 becomes 1. 1 by 5 times 5 is 1. Assume the bracket term as alpha. First observe at which instant the changes are occurring for y of t. Observe equivalent alpha, t plus 0, alpha minus 1. T plus 1 is minus 4, t plus 3 is minus 10. 0 to 1 RAM function is for original interval minus 4 to minus 1. 1 to 3 is minus 10 to minus 4. If any one of you are having doubt, you know extend how to get x of minus 3t minus 1 also you know. Draw 100%, you will get that graph yt. 100%. There is no need to think of the reverse operations to be done, sir. That is quite lengthy. So this is easy. Very good. At least 5-6 fellows have given some positive response. Other fellows tried. That is a good sign. Another simple question I'll ask you, respond. Let x of t 0 for t less than 3. For what values of t following signals are guaranteed to be 0? If original signal amplitude is 0 for t less than 3, for what values of time the addition and product of these signals become 0? Think of and respond. Original signal amplitude is 0 for t less than 3. For what time this signal is guaranteed to be 0? First you check about individual signals, sir. If xt is 0 for t less than 3, individually x of 1 minus t 0 for what time and x of 2 minus t 0 for what time? Then you can think about addition and multiplication. No, Ashish. Check it. Nagarjun Rao, wrong. Dinakar, okay. Akhil, okay. X of 1 minus t is 0 for 1 minus t less than 3, minus 2 less than t, t greater than minus 2. Similarly, x of 2 minus t is 0 for 2 minus t less than 3, minus 1 less than t, t greater than. So one clarity we got here is what, sir? One signal amplitude 0 after minus 1, another signal amplitude 0 after minus 2. That is what we observed here. So the added signal is guaranteed to be 0 for what time? When you do addition, for what common portion both are 0? After minus 1. Here you may have some shape. We don't know. Both are guaranteed to be 0 after minus 1. But if you take product, instead of addition, suppose we have taken multiplication, sir, product of them. It is 0 for t greater than minus 2. Because any shape multiplied by constant means, any shape multiplied by 0 means it remains 0 for that interval or not. That is the correct answer. कितना आंसर दिया मेरे को? Simple problem struggling. Huh? First you solve individual signals are 0 for what time? We observed one signal 0 after minus 2, another signal 0 after minus 1. Added signal 0 after minus 1, product is 0 after minus 2, sir. Okay. Everyone draw the signal graph of this one, sir. Step function multiplied by signum. But I have not given ut. Inside the bracket, I have given u of 1 minus mod t. What is the graph of this one? U of 1 minus mod t into signum. Think of, compare with ut definition. Signum, of course, you know, plus or minus 1 amplitude, sir. Instead of ut, u of 1 minus mod t is given. So if you compare with UT definition. It is 1 for t greater than 0. T place 1 minus mod t means 1 greater than mod t less than 1. What is the meaning of modulus of t less than 1, sir? Minus 1 to 1. Indirectly, it is a rectangle. It is a rectangle from minus 1 to 1. That we are multiplying with signum. That signal we are multiplying with signum. So take the product, what will happen? Once you multiply both of them, for what interval both signals are there, sir? Only for the interval minus 1 to 1. Here 1 into minus 1, minus 1 to 0 interval, 1 into minus 1 is minus 1. 0 to 1 interval, here 1, here also 1. 1 into 1 becomes, instead of saying that as rectangle, indirectly it is given as u of 1 minus mod t. Very good, Dinakar. Okay. Now you observe r of t plus 2 into u of 3 minus t. Ramp signal multiplied by step function. R of t plus 2 means that ramp signal starts at minus 2 with slope 1 sir. What is the meaning of u of 3 minus t? Just now we studied the logic. U of minus of t minus 3. U minus t covers negative time. That is right shifted by 3 units. So if you do multiplication for what common interval, resultant signal will be there. If you do multiplication, minus 2 to 3 only. Because ramp signal multiplied by constant means ramp function remains same. See sir, at minus 2 it is 0, minus 2 plus 2. But at 3, 3 plus 2 is 5. Ramp signal multiplied by constant means ramp function remains same. Minus 2 to 3 resultant signal is there. Okay. t by 6 into try t minus 2 by 2. Think of rect t by 6 into try t minus 2 by 2. Rect t we have drawn from minus half to half, sir. Try t we have drawn from minus 1 to 1. So think of and tell me that product is valid for which interval. After doing multiplication, the product is valid for which interval? Just recollect. Rect t means we have drawn from minus half to half. Try t means we have drawn from minus 1 to 1. These two are reference signals for you. Just multiply both the signals and decide the graph, sir. Ashish Ranjan, correct. Interval correct. Trivikram Rao, check your answer. Sai Charan, correct. Interval Dinakar, correct. Try t covers from minus 1 to 1 means try t by 2 covers from minus 2 to 2. Rect t by 6 means that rectangle extends from minus 3 to plus 3, sir. This is rect t by 6. What is the meaning of try t minus 2 by 2? Try t by 2 I have drawn already. That is right shifted by how many units? 2 units. So it extends from zero to 4. Then you find out for what common interval the product is valid. 0 to 3 interval, both signals are there. Only 0 to 3. So 0 to 2, the ramp segment as it is, sir. Because ramp multiplied by constant means ramp. 2 to 3 negative ramp, here ramp means that portion also as it is. Of course, for 2 units width height is 1 means for 1 unit width what will be the height? Half. See here, 2 to 4 means 2 units width equivalent height 1, sir. 2 to 3 means 1 unit width. For 1 unit width what will be the height? 1 by, there is a resultant graph of xt. Those who have got this graph thoroughly, pat your shoulder. From my side, good. Those who got wrongly, don't be emotional. Make a try. Scaling and shifting, you must be thorough. One blunder mistake which definitely most of the fellows will do in signal subject. I am asking that question to you. Be ready. Tanuja, that is what I explained. Idhar dekho beta. Tomorrow also I will discuss one more time. 2 to 4 means 2 units width. What is the equivalent height ma? 1. X1 is giving by 1. For 2 units width, height is 1. I want the answer at 3 means for 1 unit width, what will be the height? 1 by 2. 2 to 4 width of 2 units, equivalent height 1. For 1 unit width, what is the height means? 1 by 2. Suppose I have given shifted form of the signal like this. I want a scaled form of it. I should write the answer as alpha t minus t naught or alpha into t minus t naught. Everyone should respond in the chat box. First expression correct or second expression correct? Shifted signal is scaled. Shifted signal is scaled. First expression correct or second expression correct? Respond in the chat box. Shifted signal is scaled. Exactly t place alpha t, not for the entire term. Exactly t place alpha t is correct. If I ask you y of t by 3, you should take the answer as t by 3 minus t naught. Don't write t minus t naught by 3. That is wrong. Exactly t place alpha t. Reverse way. Suppose y of t is x of alpha t. What is the shifted form of that one? X of alpha into t minus t naught, or it is alpha t minus t naught. We are available with scaled signal that must be shifted. Now you respond which is valid. First one or second one, sir? 100% first one only. 100% first one. If you say second one, you are masters in the subject already. Alpha t minus t naught is over. Already alpha t minus t naught is over. This is a blunder mistake most of the fellows will do in the subject. Be careful. Okay. Either shifted signal is scaled or scaled signal is shifted, sir. Exactly here t place. Exactly t place I substituted alpha t. Here exactly t place t minus t naught means alpha becomes common multiplier. Alpha into t minus t naught. Be careful. In the coming classes, I will make you to give wrong answer, but be careful. You should respond positively. Whatever it may be, exactly t place alpha t, here exactly t place t minus t naught. Okay. That's all for today. Tomorrow's session is morning 7 to 1. We'll continue tomorrow morning, sharp 7 o'clock. I will start the class. Good night. That's all for today. Okay, as requested by you, tomorrow onwards I'll keep black background here. I'm habituated to that. Tomorrow onwards I will change it. Okay, it's not a big issue. Okay. Last one is very simple here. Shifted signal is available. We want scaled form means exactly t place alpha t we have to substitute, not for the entire term. So this is wrong. Similarly, scaled signal must be shifted means exactly t place t minus t naught means alpha becomes common multiplier, alpha into t minus t naught. That is what my explanation. Don't do that as a mistake.
Sir, page number 15F, sir.
1-5.
Yes, sir, 1-5.
Bolo.
Sir, here y you have taken as 1 upon minus 1/2 as signal is given minus 1/2 t minus 1.
Property क्या है? Scaling property क्या है? Del of alpha t.
1 by alpha del of t.
mod alpha del t है. Alpha इधर minus 1/2 है ना?
Yeah, minus 1/2.
After
so
that,
always we have to take mod.
Yes, modulus.
And sir, last question of today's class.
Yeah.
Sir, can you explain this once? I didn't understood.
This one.
No, after this. Last question.
क्या हो गया?
Sir, this question explain this.
बोले तो कहाँ से कहाँ तक है? माइनस हाफ से हाफ तक. रेक्टी बाई 6 बोले तो एक्सपेंड होता है ना, -3. ट्राई t by 2 -2 से 2 तक रहता है. उसको राइट शिफ्ट. सो कहाँ से कहाँ तक?
ट्राई कैसे -2 से कैसा रहता है?
अरे ट्राई टू -1 से -1 से 1 तक लिखा ना.
हाँ.
ट्राई t by 2 बोले तो एक्सपेंड होना है ना.
हाँ, यस सर.
इसीलिए वो राइट शिफ्ट हो गया. 2 यूनिट्स राइट शिफ्ट हो गया.
Yeah, understood, sir. And how you got final signal that I didn't understood?
Just multiplier, ramp multiplied by constant means again ramp na.
Ramp, sir. Yes, sir.
0 to 2 positive ramp I have that segment as it is.
Yeah.
2 to 3 here negative ramp, here constant means that negative ramp. At 3 to downwards. So
okay.
Taken 1/2 amplitude for 2 units width. 2 to 4 means 2 units width I have height of 1. So for 1 unit width, what is the height? Half.
1/2. Yes, sir.
Okay.
Yes, sir.
Oh, yeah.
Understood.
Right.
Thank you, sir.
Right.
Sir, in 13F. सर यहाँ पर x of t 2 कैसे आया, समझ में नहीं आया सर मुझे. x of t 2 how we got x of t?
जो कुछ लास्ट प्रॉब्लम अभी बताया ना मैं, ऐसा है. 2 यूनिट्स विड्थ का हाइट क्या है? इधर देखो 2 यूनिट्स विड्थ है ना, एक्स एक्सिस पे हाइट कितना है?
4.
हाँ, फॉर 1 यूनिट विड्थ पे कितना रहता? Simple maths ma, x1 is giving y1, x2 is giving which value? For 1 unit width 1 into 4/2, how much?
2. Okay, sir.
वही है.
And 21F.
Tell me.
Or not transform, sir. वो for x of t equal to 0, t less than 3, what is the value of t for guaranteed to be 0? Guaranteed to be
25. 8. Tell me.
Sir, can you explain this once again?
xt is 0 for t less than 3. It is asked for if they want to create a new signal like x of 1 minus t, x of 2 minus t, they are guaranteed to be 0 for which interval? First you solve. As xt is 0 for t less than 3, x of 1 minus t is 0 for which time you solve? T place 1 minus t, solve.
T greater than -2.
T greater than 2, -2, t greater than -1. If I am doing addition, both signals are 100% 0 for which interval? After -1 if I do addition. But if I take product, 0 multiplied by some shape is 0 or not, ma?
Yes, sir.
So it is 0 for t greater than -2. Over.
Okay, sir. Thank you.
Right. చెప్పు కరుణాకర్.
సేమ్ పేజ్ సార్.
టెల్ మీ కరుణాకర్.
ఇక్కడ x of 1 minus t, x of 2 minus t అంటే యూజువల్ గా 0 0 తీసుకున్నాం. సో బోత్ ఆర్ జీరో కంప్లీట్ ఎక్స్ప్రెషన్ జీరో అవుతుంది సార్. సార్ ఒకటి ఆల్ఫా ఇంకోటి మైనస్ ఆల్ఫా అంటే సమ్ ఏదో కాన్స్టెంట్ ఒకటి ప్లస్ ఒకటి మైనస్ అవుతే అప్పుడు కూడా జీరో అవుతుంది సార్. అలా ఛాన్స్
అట్లా ఓన్ క్రియేటివిటీ వద్దు. ఎక్స్ ఆఫ్ ఆల్ఫా టీ ప్లస్ బీటా ఆల్ఫా జీరో అయితే ఉంది అట్లా వద్దు, జనరల్ గానే చేయాలి. యూ షుడ్ సాల్వ్ జనరలీ. ఓకే
ఓకే సార్.
రైట్.